of ounce swing weight. So the racket itself is 68.5 centimeters long, which is 27 inches, all intents and purposes. Actually, it's 26.968, but we'll call it 27 inches, of course, and that is after stringing. So it's not going to get any shorter than that. Hopefully, it shouldn't get any shorter than that. Also on the RDC, there are three functions: RDC power, and the returns the value of 48 out of 100. RDC control, which is 50 out of 100. And RDC maneuverability, which is 77 out of 100. So you can see the low swing weight contributes to the maneuverability in a big way. Okay, that racket is very, very maneuverable, which means you can get up and under a ball and really crank it if you have to, or if you want to. You know, you don't have to, but if you want to, you can really get that racket head down and bring it up at a really, really good angle at high velocity, and going to get some good rotation on the ball. And the center of percussion, which we measure for every racket, is 21.1 inches from the butt cap, and that is when you hit the racket in that position on the string bed, that is the center of percussion, and it's going to return probably the best feedback feel you can get. So that's important, I think, to know that. We knew a maneuverability value, which is the reciprocal of the power value. Maneuverability is 1.029, which is good, versus a power value of 0.97. Those are reciprocals, so it's pretty easy to figure out what that means. If the power goes up, maneuverability is going to go down. If you have a 1-to-1, you've got probably a pretty good unit in your hand. But this is not bad. I mean, it's typical, I would say, of a player-style racket. The power calculation is a number we take based on the length of the racket, the face size, the stiffness, the weight, the string bed stiffness, and this one has a power calculation of 1807.7. That's pretty good for a racket of this type. Not the most powerful racket, obviously, but again, you're not looking for power. You're looking for a racket that you can really work with, get it around in a hurry, and do it. It'll do exactly what you want it to do. And the calculated swing weight we also do, because this calculated swing weight is taken from the edge of the butt cap, from the very longest part of the racket, and we had a RDC swing weight of 315. The calculated swing weight is 338. So what we've done is essentially take the player and the RDC machine out of the equation and calculate the swing weight from the very, very butt end of the racket. So it's going to be a little bit different than the swing weight on the RDC machine or other machine, because it swings the racket around a 0.4 centimeters, 4 inches, 4 inches from the butt cap. So there's a little bit of difference there. So that's why the numbers are different. If you read the report on the website, you'll see that difference. And here's a number we just mentioned earlier on, but this is the effective number that we calculate. And the effective stiffness is essentially the product of the reciprocal of the string bed stiffness and the reciprocal of the racket stiffness. So in other words, which we do, we also calculate it comes out to 27.2, and that's pounds. That's exactly what the resistance is felt by the ball in your hand when you collide with this setup, the string bed stiffness and the racket stiffness, 27.2. And if you, for example, on one of our machines, we can hold the racket at the grip and put the load directly on the strings, not touching anything else. And we can apply the load, and it will normally be very, very, very close to that 27.2 as well. Okay? So, and one of the things we were talking about a minute ago about the head shape of the Yonex being high-shouldered, low-hip ellipse is that the calculated area of the racket is 94.1 square inches. And we know that it's 97 because Yonex tells us it is. And we can calculate that added area quickly if we wanted to. But this is a basic calculation that we do for all the rackets. So you're going to see that if you're watching the review, reading the review, you're going to see that 94.1. It's actually 97. The torsional stability, as we talked about quickly before, was 14. And the recoil weight, which is the weight that the racket feels like when a ball hits it in the center, this is what it feels like against the palm of your hand. And it is 156.18, which is pretty good. I'd like to see it in the 160s. But if the racket is not moving, and you're holding the racket up for a volley, for example, it's going to feel like it weighs 156.1 grams, okay? So a little bit more mass there wouldn't hurt that at all. The head width, we measure all these electronically. Head width is 9.55 inches, 26.2 centimeters wide, and the head length is 12.54 inches, which is 31.85 centimeters, which gives us a calculated head area of 606.9 square centimeters. So you can see that's still a little bit less than 97, but nonetheless, those little high hips and high shoulders will certainly add the 3 square inches to make it a 97. The number of mains in this racket is 16 by 19, and it's typical of most Yonex rackets, except the new HD now is 18 by 20. And it's a very, very standard conventional string pattern, and we'll talk about the spacing just in a few minutes here. And the ratio, this is the natural ratio of the racket, and this is what calculates our cross-string tension for us, is 0.641. In other words, the main string goes in at 100, which is not true, but it means the cross string would go in at 64.1. Okay, which doesn't happen, but that's the ratio, and that's exactly what it means. So the dwell time, and again, I didn't add a person to the dwell time, so this number is strictly a ball hitting the string bed and bouncing back. No swing involved, no anything, but it's 9.09 milliseconds. Okay, and you'll find that most swung rackets are going to be in the 4.5 to 5 milliseconds. So, but I wanted to take the player out of the equation and essentially tell what it is by itself. Now, what you do with the swing is entirely up to you. If you don't swing the racket, dwell time is going to be long. If you do, the ball's going to pop off a little more quickly. So the main grid is 7 inches, and that's the distance between the two main strings. And the cross grid is 10.3 inches, which is the distance between the top cross and the bottom cross. And that is the density. We calculate the density. In other words, in this particular case, 0.766% of the racket is covered by string. Okay? And that changes with every string pattern, for example. So it's not a big deal. It is a big deal, but I mean, it's not something that you have to think about in terms of going out and demoing a racket. You don't have to ask the racket technician what's the density of the string bed, but you can look it up if you go to the website and look at this review. But the dynamic tension, this is done with the Beers tensometer, master tensometer, is 33 kilos per centimeter, and that means simply that it takes 33 kilos to deflect that string bed 1 centimeter. And as we talked about before, we take that calculation up to pounds per inch, and that would calculate to 184.57 pounds per inch. I think in a recent podcast we talked about string bed stiffness in terms of those numbers, I believe. If not, go back and take a listen to that and see, because that is the dynamic tension in pounds per inch. But the ERT gives it in kilos per centimeter. The next thing on the list, as you'll see or hearing in this particular case, is the first moment, and the first moment is what the racket feels like when you pick it up. And typically, you pick it up and shake it up and down. You don't take a big swing with it. That would be the inertia. But the first moment is that leverage you feel in the palm of your hand. And the higher the number, the more leverage you'll feel. The higher the number, typically, the more power the racket can generate. And that is 0.804, and that's a good first moment. The twist weight is a number that we calculate that is the resistance of the racket to twisting in your hand and a mishit. And I know you guys, and you especially, don't mishit the ball, but if you do, it's going to feel like it weighs 221.85 grams. Okay. So the higher the twist weight, the better, and that's calculated, and for this racket is 221.85. The string diameter, which we're not reviewing that, but it's important. The string diameter in this particular case was 1.19 millimeters, very, very thin. It was a string that's in evaluation stages, and it is a terrific string, wonderful material, but it's very, very, very thin. So it's going to give you a lot of stuff. One of them may or not be durability, but we have some history on it now, and the durability is fine. But again, 1.19 is a very thin string. So if you're reading this review, you might take that into consideration. You might try it because it's really terrific stuff. But the average cross spacing is 0.542 inches, and that's important because the higher that number, the more the strings are going to move around. The more they move around, the more they're going to notch, and the more they notch, the more quickly they're going to blow out. So that's an important number. And the main string spacing is 0.438. So that closes that gap a little bit. The average cross space 0.542. And you've got a spacing of 0.438 for the main string. That little grid now is going to be fairly tight. Okay, so it's not going to be moving around a great deal, but just enough to give you that little bit of spin if you're able to get under the ball and rip it with some velocity, which you can do with that swing weight. The variation between setting and string bed stiffness is a unique number to us, and it's 89.1. Is we set the machine at X, and what it comes out in terms of data, it's 89.1% of that. It doesn't mean much for anything except us, of course, and the short side string length is important, and is typically added to the review in a standard length, so we know where we start. In this particular case, we started at 9.7 feet for the short side, and in fact, that finished string length can be 9.2 feet, and the length total could be 35 feet. So that's not what you see in the review is what you might start with if you don't know. Okay, that's why it's included in the review. This is what you should start with. And the string bed deflection, and this is the number that we use for taking the Flex 4 stiffness number. The deflection is 0.312 inches, and that number has been used by us for many years, and is based on high-speed photography of how much the string bed changes and moves on a standard baseline rally, for example. That can be changed if we want to change it any time, but right now we're using 0.312. So on the Flex 4, the absolute string plane stiffness, ASPS, is 65. Okay, so we convert that then into pounds per inch, and that's 157.05 pounds to move that string bed 1 inch. That's good information for us, for sure, to know that. And the flexibility of the frame with the Flex 4, which just takes it a little differently than the RDC,